Hey, sixth graders, welcome back. We're gonna work on a cool problem today. I think it's cool. It's a pool problem. It's about looking at two different pool designs, and these are our two pool designs, pool one and pool two. And it's trying to figure out which one's bigger. Obviously, they're both made of complex or composite shapes. The first one you can kind of see them. There are three shapes, maybe four if you break the triangle into two different shapes, or you could just say three. And the other one has either three shapes or possibly two shapes, depending on how you think about it. But what I wanted you to do is look at the dimensions. The dimensions on each one are similar, right? In the way that the pool sizes are roughly they're close. They're close in terms of the dimensions. And my question for you is which one do you think is bigger? So look at the numbers and kind of think about which one is bigger, right? It's a little tricky. But what I'm going to want you to do today is write both of these, draw these in your notebook or on graph paper. You don't have to draw them perfectly accurate, but I want you to sketch them out. You can trace them off your screen if you want to. And then I want you to calculate using what we learned yesterday about composite shapes and transference. I want you to calculate how do we figure out which one of these is bigger by comparing the area, their total area, or the size of their area. Now, the pool thing. These are both kind of crazy shapes for pools, but I wanted to show you a new pool that's opening in London this month, and let's see if it moves with me when I move over here. This is in a kind of a pretty fancy area of London. I'm going to move my head over here. Check this out. This is called. Oh no, that's not what I wanted. Oh no, I lost my page. Which you know how I had like the right one and it lost me. Maybe it's this one. I lost it. Okay. Bing. I don't know why I'm using Bing, but it's killing me. So this is the pool that is connecting two buildings in London, and you look at it from the bottom. So like that you can see it from the ground, connecting these two buildings on the rooftop. Now London is not a warm climate; they get a lot of cold weather, so it must be a heated pool. But I'm looking at this thing. Oh my gosh! Would you swim in that? Would you take a dive or would you swim across that thing, a glass transparent pool? So this thing is opening this month in London. Look at that. Isn't that amazing? Let me see. Look at that picture. I love that. So that's a parallelogram, by the way. But in any case, this is a pretty simple shape. So finding the area of this one would be easy, but I just wanted to show you how cool that is. Wouldn't that be amazing? And then see if there's a couple more. I think I had a site that was showing me more. That one, look at that picture or that photo of it. So it's opening soon. Here it is again. You see this really nice building in the background. You see the pool right here that goes from one building to the next. Oh my gosh. What do you think? You want to go live there? Come on, guys. We can afford it. It's probably only like $2 million to buy a place in that building, maybe more. But there it is again. Look at that. How amazing. So look at all these buildings in London. London's the capital of the UK, capital of England. And, a lot of construction. Looks like a lot going on there. It's a big city, very big city, and quite expensive. So they can afford to do this crazy stuff and charge a ton of money for those apartments or those condos. But how cool is that? All right, let me see. Is that enough? Did we get enough shots? Are you impressed? Do you want to go move to London and buy a $5 million apartment so we can like swim in that pool? What do you say, guys? We can all put our quarters together. All right, love it, right? Isn't that cool? So that's what we're setting up right there. I love that image, right? Um, Okay, the pool problem. What I want you to do today's problem is figure. Oh no, there's my face. Okay, I thought I had blocked out some of the screen. So we want to do is we want to find the area for each of these, and I'm going to kind of give you a little bit of a starting point here. One of the things we know when we do composite shapes is that we start to break things down. So like we say, what is the different shapes? What are the shapes? So here I see a parallelogram. I see a rectangle, and I see a triangle. So then we try to find the base and the height for each of those, right? And one thing that we might want to look at is if this is a parallelogram, what's the height? I can say this would be the base right here, like this might be the base of my parallelogram, the base, right? But what's my height? So my height would have to be like a dotted line going this way, right? And when I say that, what I want to know on that parallelogram is what is the dimension of that purple line right there, this 90-degree angle coming off right there. What's that dimension? And the way I might figure that out, I know the entire dimension here is 24 from this point, right? The way you show this is like an arrow right here. That whole thing is 24. But what's the dimension of just this part of it, just that height right there. So I might want to look at the 5 and the 11 and say, wait a second, that 5 and that 11 are both parts of this 24, right? Like they're both on this line. So what's left over? Like what is this dimension right here? What's left over? So I want you to find the area by finding the parallelogram, find the rectangle, find the triangle, right? Now, the other thing to pay attention to is this idea of transference. If I know that this is 14 over here, that gives me some pretty good hints about what this one's going to be, because this is a parallelogram, right? Pretty cool. And over on this one's actually quite a bit easier, I think, to figure out, because you don't really have to fill in anything. You don't have to find anything. Everything's kind of given to you. But on this one, you just have to kind of like do the quick takeoffs, like the area of a triangle, area of a parallelogram, draw it out, figure it out. Which one do you think's bigger? It's interesting. I'm not sure. When I look at the numbers, look pretty close, but which one takes up more space? It's kind of an interesting question. Now, so that's your problem today. That's it. Like, this is your problem for Tuesday. Not a little hard, but I like this problem. I also want you to look. I'm going to start assigning Khan Academy for this week, so you can, if you get this done, you can work on that. But make sure when you turn this in, here's what I want. I'm going to give you a list of what I want. I want the drawings. So you got to draw each one. Right? These are notebook problems, right? These are in your notebook. Draw each pool. You can trace it if you want. Okay. Next thing I need is calculate each area. Calculate the area and show what you did. Like break it down. Calculate each area. Okay. And that's all the parts. So we're going to say all parts, right, of the pool. I think I'm going to run out of I can just go back. I'm going to say all parts of pools. Okay. And the last thing I want you to do is find the which one's bigger. Which one's bigger and by how much? So which is larger and by how much? Okay. So this is what you're working on. And remember, when you're doing a problem like this, you want to kind of like I said, you could trace it, but this idea of kind of being clear about what you're doing and where you're doing it. So yesterday when we did the problems, I was trying to be very clear about which parts were broken down and how we break it apart. I want you to do the same thing for these. And the numbers are a little big. Remember, triangles, you got to cut the area in half. People always forget that. Remember, parallelograms is just a base times height, but 90 degrees, base times height. It doesn't work. It works better when I'm in the classroom. I can say 90 degrees. Okay. But yeah, good to go. And remember how cool that pool is in London. It's called the Sky Pool at Embassy Gardens. It's opening up this month in London. Amazing, right? I want to go there. I want to go see that. All right, I need to make more money. You think I can get a raise? If I talk to Janice Jackson before she leaves CPS and say, hey, can you just pay me like a few million extra a year? Come on, like, can I have $3 million a year? $3 million a year, I might be able to go afford a place in London. All right, kiddos. You guys are great. Have a good week, or have a good Tuesday. I will see you on Wednesday. Bye. Now, how do I turn this off? I say this every time.